The most common data structure you use in Java is just a simple array. The second most common is a list. The third most common is probably a map, which is also sometimes called a lookup table or a hash table or an associative array. So the idea of a map, and hash map is the most common one, is that it associates keys with values. You store values associated with a particular key, and then sometime later you provide the key and get back the associated value. So the first thing you have to do is store a value associated with a key. So to do that, you declare that you have a map, and you give types in angle brackets, but there's now two of them. The first type in angle brackets after map is the type of the key, and the second is the type of the associated value. So this says, I am going to make a lookup table where I store a person associated with their employee ID. And I'll say that person is a class and an employee ID is a string. And so I will store person objects associated with an employee ID. And later on, once I've built this big lookup table, I'll pass in an employee ID and retrieve the associated person object. So I say map, and I provide the type of the key and the type of the value. I supply the variable name. And just like with list, I use the concrete type on the right, hash map, and the interface type on the left, map. Then to store a value, I use put. The first argument to put is the key, so this is a string. And the second argument to put is the associated value. So this says, I am storing the person, Larry Ellison, associated with the string A1234, Larry Ellison's employee ID. And then later on, I'm going to take a whole bunch of employee IDs and find the associated person. Maps can only go one way, from the key to the value, not from the value to the key. All right, so once I've stored some data, I might want to retrieve it later. And the whole idea of a lookup table is you create the table once and you retrieve out of it many times. So when you call get, you provide the key, and it gives you one of two things. It either gives you the associated value, or if there was no match, it gives you null. All right, so how long does it take to do these various operations? Well, as I'll mention at the end, to answer this question, you have to make some assumptions about the hashing function. But those assumptions rarely come into play. Most of the time, those assumptions are safe. So I'll just give you the normal situation. To insert something in the table takes constant time. In other words, inserting something into a 5-element hash table, hash map, takes the same amount of time as inserting into a 5 million element table, a 5 million element hash map. How do they do that? Retrieval also takes constant time. Retrieving the value associated with a key, in other words, you pass in an employee ID and you get out a person, or you get null if there's no match, takes the same amount of time if there are 5 entries in the hash map as if there are 5 million. Unbelievably fast. It seems magically fast. How could you possibly be any faster than that? But maps are limited. You can't say, give me all the employees whose employee ID starts with A. Doing that would require you to look through all of them. You can't do case-insensitive matches if it starts with A or capital A. You can't go from the value to the key, only from the key to the value. But if what you want is go from the key to the value, hash maps are as fast as you could possibly get. If you wanted to go the other way around from the key to the value, you'd have to look at everything, and so it takes order n, in other words, linearly associated with the size of the entries. Now, again, I mentioned that there are some assumptions underneath this, but those assumptions most of the time are safe. And so you can think of hash maps as being lightning fast for insertion and lightning fast for retrieval, regardless of how big the table is. All right, so here's a quick example. Suppose I have 2 values, a state name and a state abbreviation, like this. And I have them, say, stored in arrays right now. If I'm just going to look up those entries a few times, I could just leave them in the arrays. I could just loop down the arrays and compare to the first entry of the subarray until I find the value I want. But suppose I'm going to do this thousands of times, millions of times, billions of times. I have some sort of lookup service that's being used by the post office, and I'm going to pass in a state name like Alabama, and I'm going to get out a state abbreviation like AL. It's worth the effort of copying out of the array into a hash map once, so then I can retrieve against that hash map millions of times. So I make a hash map. There's the type. There's the concrete value. And then I loop down the arrays, and I do a bunch of puts. The first entry in the subarray is the key, Alabama. The second entry in the subarray is the associated value, AL, which means later on I'm going to pass in state names, and I'm going to get out state abbreviations. You cannot go the other way around. You can't go from the abbreviations to the states. If you want to go both ways, you have to make two hash maps. All right, and then I have some sort of routine where the user can pass in a state name and get out a state abbreviation. You do that by calling get. If the return value is null, that means there is no associated state. All right, so again, the idea is you go to the effort of storing it in a hash map once so you can retrieve against it many times.